Question 13. Question 13 was actually created from question 12. We tried to make the ratio question harder by including algebra in it. Let's attempt it. Jason and Mark shared some sweets in the ratio of 2 to 3. Jason, who received the larger share, received 4x sweets. Like in the previous question, Jason's ratio is 3 since he received the larger share, and the larger share is the same as the larger ratio. So Jason's ratio is 3. He received 4x sweets. So if this were to be 10, it will be equating his ratio to the number of sweets he got. But in this case, we're given the number of sweets he got as 4x. So we have this is equals to 4x. That's for Jason. For Mark, he received 2x plus 2 sweets. His ratio is 2 and he received 2x plus 2 sweets. So we have 2 for Mark's ratio should equal or is equivalent to 2x plus 2 sweets. You see, the ratios are on one side, the number of sweets they got are on the other side. You might at first glance believe or think you might not be capable of solving this question. But in a case like this, you should apply the rules or the processes involved in solving a question like this. In this case, this is a ratio question. So you apply the ratio processes in attempting the question. You're having a ratio question with algebra in it. That shouldn't be too complex. This is for Mark, so you can write Mark here. So like in the previous question, we cross and multiply. You take 2 times 4x on one side, 2 times 4x equals, on the other side, you have 3 times 2x plus 2. 3, open bracket, 2x plus 2. You should be careful here. This is one entity. And since this 3 is multiplying the entity, it affects both the 2x and the plus 2. We have 2 times 4x. That will give you 8x equals, like I said earlier, this 3 affects both the 2x and the plus 2. And I've seen students just multiply the 3 by the 2x only, which leads them to the wrong answer. So we have 3 times 2x will give you 6x. Then 3 times 2, this is plus 3 and this is plus 2. Since this is positive and this is positive, it's easier. You can say positive times positive will give you positive. 3 times 2 would give you 6. We take this 6x to the left. So we can have x on one side and the plus 6 on the other side. So we have 8x. This is plus 6x. If it crosses the equals sign, it becomes minus 6x. Standard in math, you say subtract both sides by 6x, or you say add minus 6x to both sides. It still gives the same effect as saying plus 6x crosses and becomes minus 6x, because it makes solving maths questions easy. This equals 6 or plus 6. We're looking for x, so 8x minus 6x will give you 2x equals 6. We're looking for x, so we divide both sides by 2, which is the coefficient of x. So divided by 2, divided by 2. 2 cancels 2. X equals 6 divided by 2 would give you 3. X is 3. Since we now know x is 3, we can then find the number of sweets Mark received. Mark received 2x plus 2 sweets in algebraic form, and we know x is 3. So for Mark, we have number of sweets he received as 2x plus 2. We know x is 3, so we change the value of x here to 3, and the x is linked to the 2 by times, so you have 2 times 3 instead of x plus 2. You have to follow the rules of button math, particularly in this case where you have to multiply first before you add. So you have 2 times 3, that's 6, plus 2. 6 plus 2, you have 8. So Mark received 8 sweets. So Mark got 8 sweets. Question B says, how many sweets did they share? To know the number of sweets they shared, you have to find Jason's share. Jason's share in algebraic form is 4x. So for Jason, we have 4x, and the value of x is 3. So we have 4 times 3. You change the value of x to 3. And the x is linked to the 4 by times. So you have 4 times 3, that will give you 12. So Jason got 12 sweets. Mark got 8 sweets. So the number of sweets they had to share will be 20. That's the number of sweets Mark got, which is 8, plus the number of sweets Jason got, which is 12. So 8 plus 12 will give you 20. So they shared 20 sweets. In summary, this question is a more complex version of question 12 that can be described as a ratio question with a touch of algebra. That is, a complex question made from 2 topics. You could have one made from more than 2 topics. And to attempt such questions, you need to identify the main or major topic which other topics are attached to, while having in mind the rules and processes guiding all topics involved, and apply accordingly. In this question, the main topic is ratio, with algebra attached to it. To solve this question in particular, you have to use the ratio process or principle to first put it in order, then find x first. Once you found x, you can now use x to find the number of sweets Mark received, then the number of sweets they shared. Apart from using the first method to solve this question, there's also what we can describe as the traditional method of solving this question, the one we're actually used to. Let's apply to see if it's actually easier to use this method or the previous method. Jason and Mark received some sweets in the ratio of 2 to 3. Jason, who receives the larger share, received 4x. Mark received 2x plus 2 sweets. So, normal standard way of solving a ratio question is the ratio of a person over the total ratio times, in this case, the total number of sweets they shared would equal to the number of sweets the person got. For Jason, he received the larger share, that his ratio will be 3 over the total ratio, which is 2 plus 3, that's 5, times the total number of sweets they shared, that will be 4x plus 2x plus 2. Let's say, for example, Jason received 10 sweets and Mark received 8 sweets. So it will be 10 plus 8 to get the total number of sweets they shared. So in this case, it will be 4x plus 2x plus 2. 4x and 2x are like terms. So we have 4x plus 2x, that will give you 6x. Then you have plus 2. Plus 2 is not a like term with 4x and 2x, so you leave it as plus 2. So the total number of sweets they shared is 6x plus 2. So we have this as 6x plus 2 should equal Jason's share in this case. Since he received the larger share, thereby having the larger ratio, we will have it as 3 over 5 times 6x plus 2 should equal the number of sweets he got, which is 4x. All we are trying to do is to see if we can find x first. Then we can get the number of sweets Mark got and the total number of sweets they shared. Rather than even use Jason's share, we can also use Mark's share to get this. We'll still get the same answer for x. Then we can use the x to get the actual numerical value for the number of sweets Mark got. So we have this over 1, we can say 3. This 6x plus 2 is one entity, so you have it as 3 into open bracket 6x plus 2 close bracket over 5 should equal 4x. You have to be very careful with this line. This is one of the reasons why some students struggle with math. It's not as if they find it difficult to understand, but they just mix up principles or basic laws, or what you can also term rarely discussed facts or points in math. So this is an entity, and this 3 affects both the 6x and the 2x. Let's open the bracket first at the numerator level. You have 3 times 6x will give you 18x, plus 3 times 2 will give you 6 over 5 should equal 4x. At this point, we can make this over 1 because we want to cross multiply to get this 5 off the left. Standard in math, you would say multiply both sides by 5, but it has the same effect as saying you cross multiply. So we have 5 times 4x on one side, 5 times 4x should equal 1 times 18x plus 6. Anything times 1 is that same thing. But let's just put it out so you can get the step. 18x plus 6 is one entity, you put it in brackets, times 1. We have 5 times 4x will give you 20x. It's 5 times 4, that's 20. Then you join the x to the 20. Equals, anything times 1 is that same thing. 1 times 18x will give you 18x. Then the 1 also affects the plus 6. 1 times plus 6 will also give you plus 6. Next, we take this 18x to the left so we can have our x's on one side and the constant on the other side of the equal to sign. So we have 20x minus 18x equals 6. 20x minus 18x will give you 2x equals 6. We're looking for x, so we divide both sides by 2. 2 cancels 2. X equals 6 divided by 2 will give you 3. So x is 3. And this doesn't represent the number of sweets. It's just going to help us get the number of sweets Mark got. So since Mark got 2x plus 2 sweets, and x is 3, we have 2x plus 2 as Mark's share of the sweets. Then x is 3, so you have 2 times 3 plus 2. 2 times 3 is 6 plus 2. 6 plus 2 is 8. So Mark received 8 sweets. We know Jason received 4x sweets. So using x as 3, we have 4 times 3. We're changing the x to 3. That will give you 12. The result, which is 12, plus the number of sweets Mark received, which is 8, would give you the total number of sweets they shared, which is 20 sweets. Hope you understand. Using the second method is just to show you that in math, sometimes there are more than a way of solving a question. And in this case, it's best you understand both methods and apply whichever you're more comfortable with or which is more acceptable in the exam.